Hi, I'm Jake. I'm an intern in the engineering and tech department here at Glidewell. Right now we're in the FedEx building. There's a lot going on, R&D, engineering, the warehouse, machining's all down here, and especially BruxZir factory, and I'm going to show you guys around. All right, this is the engineering warehouse. There's a lot that goes on in this room as well. Testing, final assembly, it all happens here. This wall full of parts is awaiting final assembly for machines going to Memphis or machines sticking around here at BruxZir factory. Testing also happens here. Today we tested this infiltration system, which has been in the works for a long time, about 6 years, and it's finally coming together. And the primary function of this machine is to essentially put the solution on top, and the solution stains from the top down. It essentially gets rid of a portion of the hand coloring aspect. Should save Glidewell a lot of money in the long run. It'll take the puck, like this puck here, this blank. This example's pretty beat up, but they would load this in, and this clamps around it with a pneumatic clamp. One nozzle deposits yttrium nitrate, which essentially is just a stain, and it stains it from the top down. And then this whole table, while it's still clamped, flips over, and then the second nozzle will dispense water on the other side, which will create a nice gradient of staining through the puck like a tooth. Because a tooth is stained, it gets dark at the root and lighter towards the top, and that's essentially what this is doing. It's essentially removing another aspect of staining. There's also a proof of concept machine, so it's also semi-automatic, but hopefully the idea is that you could automate the loading process, and that's what makes it fully automatic. So a lot of people have dedicated a lot of time to this. Like I said, 6 years of work. It's a really cool machine. Other than that, it's workbenches, anything to make a quick fix or modification. This machine here is a compact milling machine similar to BruxZir factory. It would go in something like a sister lab, so they can make crowns faster and on site. And these are 2 dewax stations that are going to Memphis as well. This is actually a really good way to see it because the other one in BruxZir is full of water. But there's actually slots down here that lets the water pass through. So there's basically 3 separate holding areas, and essentially siphons the water through in a big S. By having the water snake through, we're giving the wax more time to rise, essentially. It lets some wax settle at the front, and the remaining wax settles in the middle, and some settles all the way back here. And these 3 wheels, the wax loves to stick to things. It sticks well to itself, and it sticks well to practically anything. So these wheels are in the center, and they rotate and pick up the wax. And then these scrapers can be adjusted. That's why there's slots here. Just scrape off the wax, and it'll tumble down. There'd be containers here as well. So then we can dispose of the wax or reuse it, depending on, I don't know if we could, but we probably could. We'll see a working version of those inside the BruxZir line as well. So this is the start of BruxZir factory. There's a lot of cool technology going on here. The first step is essentially that these trays of single-tooth blocks, single-tooth crowns, get loaded in, and essentially this arm is gonna scan the code of one of the blocks, which has all of the patient's information, and more critically, the information and the shape of the crown, the geometry of the crown, is all loaded on that barcode on top of the block. All that info is then deposited into the system from the barcode, and that essentially is what gives this whole system the information to know what to mill and how to manufacture the crown, since we're on a per patient basis. Everyone needs a different crown, different geometry. So that's what this arm is for. It'll scan through, and it'll pass it off to this next arm. And this arm will deposit it in one of these milling bays. You can see the block being loaded in and the drill bits and the actuators milling out the crown. So we mill one side of the block, fill it with wax, mill the other side, the wax keeps the tooth suspended in the mold. There's no need for stems, which create, circles on the crowns, which are generally undesirable. So the wax gives us a clean crown. Once it's done being milled, this arm will retrieve it, pass it off to the next arm, and it'll deposit it in one of these trays. At this point, inside the block is a crown suspended in wax. So the next logical step would be to melt the wax off. So we have two machines, two processes essentially that aid us in melting the wax off. So after it loads up a tray, it'll enter our dewax tunnel. The crux of this tunnel is it supplies hot water directly over the tray. There was a deposit of the breakaway shells. These are actually really hot, so I'm not going to touch them. But once those cool, that's the only byproduct. So once this tray is full, it'll enter this tunnel, and I'll actually remove this tunnel here. This jet is essentially pounding hot water to melt the wax, and the crown will fall through. So this tunnel gets about 80 to 90% of the wax off, enough for the crown to fall out of the block. And here you can see that once those blocks were dumped away, as we saw before, this is what's left. These are custom crowns on a per patient basis. These crowns are extremely hot, and they actually still have about 10% of the wax remaining. So to get rid of that remaining 10%, we essentially torch it off with this large oven. That removes the remaining wax, and these crowns come out very, very, very hot. You can actually see a batch coming through now on this slow chain conveyor. It has to move really slow. We need to give the crowns enough time to cool off. This is the cooling chamber. It passes through an air blade right here, which basically pushes out a very thin knife of air that cools it down relatively quick, considering the footprint that it takes up. This tunnel specifically is getting revamped for Memphis, so there's a lot of optimization to be done here. We're always continually optimizing this BruxZir line. You can move over here to the first step of detailing. Once again, since it was scanned at the beginning of the line, she has all the information she needs to put on that initial coat of whatever color is needed in the root or in the various indents of the machine teeth. This is just the first step of detailing, and I'll show you a little more detailing later. But to get back to our dewax station, we're essentially left with a bunch of hot, waxy water as soon as the crowns are done passing through. Obviously, we're not going to dispose of this water, so we need a means of dewaxing the water, hence our dewax station. In here, the design of this machine is very clever. This is extremely hot, but we essentially have 3 spinning wheels that collect the wax as it pools on top of the water, and the wax is then scraped off and deposited away into these canisters. It's a really clever way of using the adhesive properties of wax, or that is the property of wax to stick to itself and to stick to other things. The wax has no problem sticking to these wheels, which removes it from the water. Yeah, this is our auto finisher machine. This is probably the most complex machine in the BruxZir line and probably on the Rydell campus. The general gist is that this robot arm picks up a tooth that has the curing elements that are already on it, and all this does is eliminate the manual feeding portion, which takes time. It also makes it safer because it has to pass through this really high temperature tunnel to cure the crowns passing through.